Okay, well, for those who are joining this live stream, we are going to be talking about some of our new blockchain functionality that's coming in version 12. And my goal is to understand some of the workflows that we are going to be supporting and try and make sure they all make sense. All right, so let's start off with a standard Bitcoin transaction here. So the basic idea is that, so wait a minute, where did that transaction ID come from?
So if you want a more complete version of these, maybe you can open the workflow.
Which workflow? So this is, which one is that? Transfer Bitcoin between addresses.
Mm-hmm.
Okay, got a lot of background noise there, guys. Okay. So create a Bitcoin private key to be used for sending Bitcoin. Okay, so this is going to be my, it's going to effectively define my account. Is that correct?
It's the first step to, to create your Bitcoin address.
Okay. All right. So, okay, so this is a key pair, but I'm only getting the private part of that key pair. What am I doing with the public part of that key pair?
You're going to use that in the blockchain key encode part to generate your address.
Okay, but this line, if I'm understanding this line correctly, this line is storing only the private key, whereas the precedence of that such that, so if I do this, and then I say, yeah, that's only the private key. So the public key just got lost here.
Well, the blockchain key encode function knows that it has to use the public key, so you can provide the public.
I don't understand. I'm very confused here. This sender key, this line here, stores only the private key. When I do generate asymmetric key pair, right, that's going to generate both private and public keys, right? Mm-hmm. But this line saves only the private key.
Yes.
Okay, so what happens here?
So here, when you provide that private key, actually, if you you expand the blob of the sender key in your notebook at the left.
Oh, no, wait a minute. Wait a minute. It doesn't give the public key in here.
No, but it has information to generate the public key. So, so the blockchain key function already knows that, and with that information, it will derive the address from your public key. So it's saving you one step.
Okay, so okay, so this is okay. So this thing here, let me just try to understand what this is doing. So this is encoding an address for that block. Does it need to know what the blockchain is? Why does it need to know the blockchain?
Because the first character is different. So how you encode it, you use different characters if it's mainnet or if it's testnet.
Okay. Fair enough.
And in this case, just as a basic example, we are sending Bitcoin from one address owned by us to another address also owned by us. Just as an example.
Okay. But so, for example, okay, fair enough. So like if I was going to use, okay, fine. So then that's the receiver. All right. Okay, I get it. So that's the Bitcoin address from that private key. All right.
Mm-hmm. So now we go to a Bitcoin testnet faucet that will give us free fake Bitcoins. And we enter there the sender key because we need to have some Bitcoins associated to that sender address. So that's how we get the Bitcoins, through that faucet.
Okay. Okay.
And that transaction ID, the one you were asking before, is basically this one, the transaction ID that the faucet gave us, which is the transaction ID where our transaction.
Okay, so there's the transaction,
Mhm.
and this is the transaction. Okay, and now you're asking for the outputs of that transaction. So that's the transaction that the faucet did.
Mhm.
Now you're asking for the outputs from that transaction, and it says, "Boy, that's a lot of Bitcoin."
Yeah, because those are the Bitcoins owned by the faucet. And the second one, the last output, is the.
Wait a minute. So this, I don't understand this. What? By the way, I've got an echo on this phone, but I don't understand what this output means.
So there are two outputs here. Remember, the transaction was created by the faucet, right?
Mm-hmm.
So the faucet created two outputs. One output is the last one, the 0.18 Bitcoins. That if you see the address there, it's our address. It's the address we created with a private key. And the first output is what they are sending back to them. Those are not our Bitcoins.
But wait a minute. That's saying that they took all the Bitcoins that were at their address, which is this thing here. Is that right?
That's the receiver.
Which receiver? That's not us. That's them.
No, that's one of their addresses. So yeah, remember when you transfer Bitcoins, you need to transfer your whole output. So
somewhere. Case, yeah, I understand. So it's transferring it back to itself, most of it back to itself, and some of it to us.
Yes, that's
okay.
Right.
Okay. So then why is their address longer than our address? Or is it an illusion?
I'm not sure. Can you check?
It may just be non-fixed width font. It's a bit odd. That's a bit odd, if I might say so.
Oh, I believe because their address is a pay to public key hash. I mean, I pay to script hash address, and our address is a pay to public key hash address. So they are a little bit different.
I didn't understand that. Explain that again.
So in our case, our address is representing a pay to public key hash transaction, which is a very standard transaction that is related to a hash of a public key. In their case, their address is representing a transaction that is related to the hash of a script. So to use our Bitcoins, we need to provide a private key. For them to use their Bitcoins, they need to provide a script. So it's a little bit different.
I see. And we don't annotate that fact that those are different. What a mess. My God. Okay. Now let's look at the script string. Okay. What is the status of our virtual machine for these?
We have a prototype.
Can you show me? Can it parse that string and turn it into some symbolic representation?
Not completely, because it needs to connect to. There are some opcodes here that need information from the blockchain.
But can I see what it can actually do? And then can you explain to me what that hash is there? What is that?
So that one is the hash of a public key.
Which is, I see, that's our I don't understand. I thought this was our public key.
That's the address. And what we are doing here, so this script string here is the unlocking mechanism that this transaction is providing. So when we want to use those Bitcoins, we have to provide a first part of the string that has a public key and a signature. That signature comes from our private key. So when you combine both scripts, they run and you get a true result. If the result is true, that means we can use those Bitcoins. So this is the last part of the script, and we have to provide the first part of the script to unlock this output and use the Bitcoins. And that will happen in the next section.
Okay, I'm a little confused by this, but okay, fair enough. Okay. A cup of amount. Okay. Okay, so wait a minute. What happened here? So wait a minute. This is, I see, this is, they had put, this is in our sender. The faucet had transferred Bitcoin to our sender, correct? To our sender's address.
Right. It created an output that is linked to our sender address. And that means that we have the private key to use this output here.
I understand, but it effectively transferred this amount of Bitcoin to that address that we specified, yes?
I wouldn't say that that it's exactly correct, because you don't transfer Bitcoins to an address. You create new outputs and you associate that output to an address. And we can say, yeah, I mean, it's easier to say that you transfer some amount to an address, but in reality, what is happening is that you are creating, it's like creating a safe with a lock that has that only your key can open, basically.
Yeah, okay. By the way, do we have nice visualizations of things like the, taking sort of a ribbon of the total Bitcoin and the faucet, how we're slicing that off? One piece goes to us, one piece goes back to the faucet. Do we have any nice visualization of that?
We made some of them, but we can prepare.
I think that will be useful for some of our educational outreach. I noticed Carl on our live stream is saying, is there a background and context section in the docs for each of these functions to enlighten non-Bitcoin aficionados how they work? A good question, and not a bad suggestion either. I mean, this is, I don't know what, let's take a look at Bitcoin transaction data. That is actually a pretty good suggestion. And maybe we should try to write that. I mean, in the end, this is complicated stuff, and hopefully we will have some courses about it. But you're aware of some of our pages, right, are starting to have, I bet there's one here, a background and context section, right?
I see.
I think it would be a good idea to try and write some of those for these Bitcoin functions to give some idea of what the function, what the point of the function is. I think that'd be great to do that, but it will not be sufficient because it's a pretty complicated area. But it will at least give people more of a fighting chance of understanding what's going on. Okay, so now what are we going to do? We're going to take the stuff that was at this sender address and get ready to transfer it to the. My gosh, this is complicated. Wow. Oh my gosh, what a mess.
Right, so now we want to transfer that money we got from the faucet to our other address, the one you also generated at the top of the node. So in reality, that will usually belong to another person, but in this case, it's just for you to test how do you transfer Bitcoins between two addresses owned by you.
Okay, well, so check your balance by inspecting the output of the transaction. Okay. That's what we just did. That was the thing we just looked at. Okay. Okay, so now convert blah, 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 blah. Okay, build the transaction object. Okay, so we want to send 0.05 Bitcoins. We are offering that fee.
Yes.
Wouldn't it be better to give that fee in Satoshis here?
Yeah, we can also do that.
If I just say, what does it do if I just say currency convert of a thing? Oh, it requests a second argument. I wonder whether it should just do based on geolocation. That's a suggestion for the currency conversion folk. I mean, I think if I say geolocation country, I will get a definite thing, and arguably I should get a definite thing, and arguably we should do currency convert with one argument should go to the local currency. Who's PMing here?
Me, Carla. I can send that over.
Could you send that, I guess, to Alan?
Okay, no problem.
Okay, all right. So how do we set? I think you should explain in this workflow where that fee comes from, how you determine that fee.
So in this case, we have worked a lot with testnet, and we know that this amount of fee is basically the fee that works for us to get a block validated in the next like 5 minutes or 10 minutes. So that's something we already.
Then you should say that. You've got to say that here, because otherwise somebody who's reading this workflow says, how do I know what this fee should be?
Okay.
Wouldn't it be interesting if we had some function that could tell one the prevailing fee? In other words, it could just look at some recent transactions and look at their fees.
Yeah, we can also do it. Let me check one thing.
I think that would be a nice thing to have. I mean, perhaps it's a function repository function or something.
Yeah, so we actually talk about having, so constantly run some stats of our different blockchains we support to get, for example, like the minimum fee and the maximum fee of the last, let's say, 10 blocks. So that gives you a better idea of.
I think it's great. So wait, how are we doing that? How would we do that?
We can check we just get the last 10 blocks and inspect the transactions.
Okay, so if I look at blockchain, data, right, for this blockchain, right? Okay. Oh, I see. Oh, there we go.
Yeah, but I think we can get more stats, not just that. I think we can get more.
Well, but that's already useful. But when you show it here, you should show how you derive that fee. Okay? And you should say, for example, it might be 20% above the minimum fee or something. You should say what you do. So like here, if I just say, get me the minimum fee here. Okay, and now I have no idea what that is. Currency convert. Okay, I see. So then what I would do here, can I edit this? Shall I? No, I can't, because your copy, I didn't check it out. But what I'm suggesting is that you put in there, show this, show the fact that it has a minimum fee, say it's 1.2 times
the minimum fee.
Right, or whatever it is. Okay. Okay. All right. So let's keep going here. All right. Change. What does this mean? This means.
So since we are sending some money to our receiver address, we also have to send money back to us, to our first.
Okay. All right. So let's build the transaction. Okay. So.
So that transaction ID is where you can find the output that the faucet generated for us. That will be some cells above. I think where I put check your balance or something like that. So that's a transaction ID, and the index is the output index. In the case of Bitcoin, you start counting from 0.
Wait a minute. I'm sorry. I missed something here. This transaction ID, where did this come from?
So if you scroll up, okay, and you see that blockchain transaction data cell.
Yeah, okay, so you copy pasted it from here. Can I suggest that in terms of the flow of this document that you say, faucet ID equals or something, or faucet equals this thing, and then you use that for these places so that it's not just a mystery thing that goes in here. Okay, so the input is that transaction. What is the index equals 1 thing?
The index, so if you scroll up, you see that we have 2 outputs, one for them and one for us, the second one.
I see, okay.
So that's index 1 because it starts.
Of that transaction, right. Okay. And the outputs in the transaction we're trying to build are an amount at that address, an amount at that address. Okay, I get it. Okay, sign the transaction with the sender's private key. Okay. Okay. Submit the transaction to the blockchain. Find the transaction.
There's a typo there that should say Bitcoin.
Bitcoin testnet. Okay, so that's the ID. I think you should show those in separate lines. Okay, don't put these together in one line.
Okay.
Have it see the transaction ID, and you can just say / dataset here. Right, transaction data equals that / dataset. Okay. Well, hopefully you will already have computed this. Check the new transaction output to verify the amount sent to the receiver's address.
That's just to verify that.
Yeah, okay, I get it.
So at the end, we are saying
crazy, if I might say so. That way, I mean, showing that just seems, I mean, presumably the right way to do this when we have system credential is to save it in the system keychain. Is that right? Or would you do it somewhere else?
That will be the idea, yes. And eventually we want to build a blockchain wallet on top of that. For now, it's just a simple example of how to save your keys.
I wouldn't say D:. I mean, that's a that just happens to be the DOS whatever. Just say private keys.wl. Just save it to the current directory. Make sense?
Okay. So that's the most simple case of.
But wait a second. But the way you're saving those private keys, don't you want to save? Well, I mean, this is an unrealistic example because you would save those keys to different places. I mean, if this was using system credential, okay, I don't understand what it would look like. Do we have anybody who knows how system credential is supposed to work? I mean, this would be system credential of whatever your name is for that thing equals, and then the private key, right? Carl on our live stream is asking whether there's something like a PEM file that is standardly used for these. I don't know. What is the standard? Is there a standard wallet format?
I think that differs depending on the blockchain. But for PEM files, I believe. Let me check. I remember.
Let's find this out because it may be that there's an import-export format that we should have, which is a wallet format for different blockchains. Okay, so let me see if I understand. If I'm going to go to the local Bitcoin ATM, okay, and I simply want to get paid, I want to convert my dollars to Bitcoin. All I have to do here, if I'm not mistaken, is let me see if I understand the flow. What I would do is I would take this, I would generate one of those, I would make sure I appropriately save that private key, right?
Yes.
Then I would go and I would do this blockchain. So here's what I would do. I would say, what I would call this is I would say it's my key equals this. Okay, so this is using a Bitcoin ATM. And I'm going to save this someplace.
Actually, there's a notebook I sent you about using a Bitcoin ATM.
Okay, well, let me see if I can figure it out for myself.
Sure.
So, okay. Okay, so I generate my key. Then I say blockchain key encode to Bitcoin, not the test net, but the main net.
Right.
Okay, and there I have this magnificent thing. Then
I basically say that as something like my address.
Yeah, okay. Actually, I want to say my key here. Okay, so now I would say barcode image of my address, my QR code. Right?
Right. And you can do like a send message using MMS to send that barcode to your cell phone, because that's
okay. Let me see what happens if I try doing that. What do? I say MMS.
So you have to write send message. The channel is MMS, and the next argument is.
Isn't the default to? Hold on, let me just see what happens here. Why is this confused? What is it doing? Okay, who knows about this? What is that? What is going on there? I am very confused. That now it's made the kernel go away. So let's take a look at send message. MMS message. So this will send it. Why isn't this working? Let's see if I can send it SMS. Let's just check that I'm cloud connected. I think I have to be cloud connected for any of this to work. Okay, that's okay. Send message. Hello there.
But you have to specify the channel first.
SMS.
I think that the kernel crashed when it was trying to auto-update the packlet.
All right.
Oh, you got something?
Hopefully. Okay, so why did it not work here?
Can you rerun to get the key and the address again, please?
Yeah. Okay. Let's try doing this. Let's see. This is sending it to some random non-real phone. Let's see whether I can pack that down. Oh, beautiful. Magnificent.
So you're seeing the QR code in your cell phone?
Yeah. I have the QR code right here.
I haven't used a Bitcoin ATM, but do they have a QR code scanner? Or how do you type your... Okay.
They do. They have a here, I'll show you what this so what should happen is I should be able to let's see. There we go. Magnificent, right? So I should be able to just hold that up to the Bitcoin ATM, and it should it should be able to. Okay, so this is very straightforward. Okay, so now I've done that. Now what will I see? So then the Bitcoin ATM will give me a receipt, which is a transaction ID, right?
Yes.
And then I should be able to go to the blockchain and see that transaction going through. Now, the other way around, what I would want to do, let's say I want to, the other part of this is, can I get the ATM to disgorge money to me, right? And for that, I presumably need to give it, what do I need to give it to have it? So this is giving it money. What happens if I want it to, well, so this would be what I would do. If I want to pay somebody else, this rigmarole is what I have to go through to take what what I put on the blockchain here, I could then pay to somebody else. But what if I want the ATM to give me back dollars? What do? I would presumably give it a signed transaction like this.
Right. What the ATM needs for you to access your Bitcoins is your private key and which output you are using. But I haven't used a Bitcoin ATM, so I'm not sure what kind of interface they have.
Well, it has a window where you show it a QR code. I mean, let's see. I'm just trying to see whether there's a I took a picture of the physical object, but this is okay. I mean, this is a typical. This seems to be a. Where is there? Sorry, I'm just trying to. So this seems to be, if this will pull over, that seems to be a typical picture of a Bitcoin ATM. Okay, so there's a camera there, and there's a place to stick money in. And maybe there's I guess what it does is it probably shows you the transaction ID here, maybe as a QR code, and then maybe you take a picture of that.
It doesn't give you the option to send you the transaction ID to your email?
Well, there doesn't seem to be a keyboard here.
Not on the screen.
Right, I'm guessing it shows it on the screen. Okay. Anyway, we can try that. All right. So let me try to understand these other workflows. Okay. So what you've got. What was this? So this is. So over here, a pay to public key hash. Wow. So
that's the name of the standard transaction.
Yes. But this is the transaction we just went through, or not?
This example here is just a more simplified version of the workflow. So workflow has all these steps.
Okay, but so this starts off with a random transaction ID.
Well, it's not random. It's one transaction ID where there's an output we know we have access to.
Right. Okay, fine. And then this is now a new transaction being done with that output.
Yes.
Okay. So one question that I would have is, what does this graph look like of, I mean, it's sort of a ribbon thing of transactions flowing into other transactions. Do we know what that looks like? Can we make that graph easily?
It's not hard to make the graph, but it takes a while because it needs to read different parts of the blockchain.
Right. But I mean, because the whole blockchain, I mean, have you seen, is there a graph that, have you seen this graph?
I've seen small graphs of transactions, and we have something like that. But it takes a little while. But
how many transactions have there been in the history of blockchain? Do you know?
No, but we can.
Obviously, we can compute that. Although it will take a while. I mean, it will be an interesting thing to record since we know it up to a point. It will be a fun thing to have in our blockchain data, wouldn't it?
Yes, we probably need a support database for that, so we don't query the blockchain each time.
Oh yeah, but for every block, we know how many transactions there have been up to that time, right? So every new block, we just have to add. So for example, if we say, so let's say for the first 20 blocks of the Bitcoin blockchain, okay, so now what would I do? I would say blockchain transaction data.
No, you can just extract a transaction list of blockchain block data, and
okay, so I just do that table. Let's say, did it start with block 0 or block 1? What was the genesis block? Was it
block 0?
Okay, but I think this is so. These
I think our function is listable. Should work with a list there.
Okay, but these all have one transaction in them, right?
Yeah, because
whereas
that's when
I were to look at a recent block. And I were to look at transaction list. And I were to look at length of that. I see. So nowadays, many of them have quite large numbers of transactions.
Usually, yes.
I'm now curious. If I go, let's see, what block number are we at right now?
If you do blockchain data, you should get the latest block.
Blocks, 500,000. Okay, so let's pick. I mean, I'm just curious if we go to block. So if I do this computation for blocks, this is just curiosity, but if I say range, let's say 1 to 500,000 in steps of 50,000 or something. So this would give us some sense. I see. So that's the growth of the number of transactions per block in the Bitcoin blockchain. It's kind of interesting. We should, in this course we're supposed to be doing about all this stuff, things like this should be part of it.
Yeah, makes sense.
now I'm just going to do the why not?
And you could also add the time mine property, so you also have the actual date and time.
Right. Okay. So right. Okay. So now let's say. I see. Okay. It gets a little bit more squiggly. Okay, that's interesting. I wonder why this happens. I mean, I wonder what the distribution of transaction numbers in a block is. That would be, is it a Poisson distribution? What is it? Okay, all right. So these are things we can, but I mean, in terms of this graph, let's see, the first, what will we have to do to find out? Let's see, we'd have to use the inputs and the outputs to find out which transactions relate to which other transactions, correct? So if I were to look at, if I were to look at the transaction, a bunch of, okay, how about, I see, I can't just say, I have to have the transaction IDs, which I have to get from the blocks. Right. Okay, I mean, these will be interesting things to do. I mean, again, we need to be getting ready our course that will explain to people like the folks, how all this stuff works. And these will be good things to have in there. Okay, so let's take a look at some more of what you've got here, and then let's take a look at how our computational fact system plugs into all of this. But okay, so we've got Ethereum transaction. Okay, so we've got the analogous transaction for Ethereum. Is that right?
That's right.
Highest gas price. So okay. So now what is this? Oh, I see. That's interesting. Okay, so there's the transaction ID. Okay, that's an interesting state that we'll be in. This is right. So when we first do it, like with the Bitcoin ATM, what we will see when we look at our transaction is pending to mine. Is that correct?
Yeah, if you just like if you get the money from the faucet or the ATM, you need to wait a while. In the case of Ethereum, it should be faster, right, guys?
It's about 10 seconds in Ethereum, more or less.
Oh, really? It's like 10 minutes in Bitcoin.
In Bitcoin, yes.
Okay. And so what we would do, I mean, we could poll. Essentially, what we're doing then is we just have to keep watching. When will it clear? Okay. Okay. All right. So that's basically just the analog of what we already saw, but for Ethereum. True? Or is it different somehow?
The process is somewhat different, but it's in general the same thing, making a transaction.
Do we have a workflow for Ethereum here for this type of an analog of that workflow for Ethereum? Yes.
Yes. But these are drafts still.
Okay. Okay. So that's a faucet. Okay, for some totally bizarre reason, the hex is quoted in capital letters for this case. Why? I mean, I don't think we really care, but I'm just curious these addresses, what matters is the hex, is the bits, right? Not the actual characters of the hex.
It is a security measure for the Ethereum addresses. It is called a checksum. It is just to verify that you didn't got any letter mistaken.
What's the checksum part of it? That some are capital letters, some are lowercase? What?
Yeah.
That's cool. Okay, but so our encoder does whatever is being done for that checksum and produces it in a format. Do we say that in the documentation for this?
I don't think so.
Why don't we say it? Just for people like me who would otherwise be confused. Okay, all right. So let's go here. Okay, our starting balance, Bitcoin address data. So that was different from the Bitcoin case, because here we're asking for a balance at an address, right? And whereas here, we did not have any such thing, if I remember correctly. Here you asked for a transaction. So in this case, there's a transaction hash here, which you're not entering here. I'm confused. Explain. What's the analogy between this case, the Bitcoin case that you're showing here, and the Ethereum case that you're showing here?
It is somewhat different because in the case of Bitcoin, the blockchain only stores the transactions, and it is up to you to take or to compute your balance. In the case of Ethereum, the actual blockchain saves the balance. So in the case of Ethereum, you just can call the blockchain and you got your balance. It is more straightforward.
Okay. And so we couldn't use, if I use blockchain address data over here, if I'm, if I say for my efforts up here, my little ATM efforts, if I said for that, right? If I said here, blockchain address data of that, comma, what would I get if I did this? What would it give me? What would it tell me if I do this?
So try. So we're actually working on making this work, but for this we also building a support database because, as Akira said, the blockchain doesn't have that information. So we're constructing a database to compute all these and return that information.
So the blockchain address data can contain, for a given address, it contains, I see. Cool. All right. Did we go over this? I guess we have. All right. Okay, fair enough. By the way, you also had given me the information about how to buy a CryptoKitty Raw. How would I do that? I mean, so just walk me through the process. If I want to buy a CryptoKitty for, I mean, if I were to look, if I were to say blockchain token data, and now I'm going to say blockchain base, or do I even need to say Ethereum? What happens if I just do, let's see, what happens if I just want the top 10 tokens, for example? Does this make sense, or what am I?
Yeah, by default, it goes to Ethereum. Okay,
but how do I, why is that failing there? Do I say like 10 or something here? No.
No.
What do I do to get the top 10?
The way you would do is you would put all, and then you would do something like part or take.
Okay, but so that is going to give me, what is that going to give me? That's going to give me, if I say data set there, that's going to give me, is that really going to give me all of the tokens?
Yeah, but just only the general information.
Okay, so there are 1,020 types of tokens on Ethereum right now, is that correct?
Well, there are two types of tokens, and there are
right. So this
thousands.
is ERC20, but what about, so is this only giving me ERC20 tokens?
No. It is only also giving you 721.
What's that guy there?
There is another standard.
So if I were to show this, just for example, for the hell of it, if I just wanted to do something here where I say, let's look at the total supply. So then let's say here, let's just, is this in any kind of order or is this not ordered? Okay, so let's just say I want the name and I want, so let's say I want line 19 and I want the name and I want the total supply. And what did I do wrong? Oh, whoops, I need to say all. Okay, so now what I might want to do is let me try to make a word cloud. Well, let me sort by. What happens if I would do this? Is this going to work? Okay. Well, I just reversed this. It's kind of cruddy, but I should have used reverse sort by. Okay, kin, whatever they are the most, have the largest total supply. So if I now say take that, comma, well, let's say take that, comma, 100, then I could say, for example, what happens if I say just word cloud of this? Is that going to work? Probably not, would be my guess. I'd be very surprised if that worked because I don't see how it can know what to do. Well, it thinks it's doing something. I can't believe it thinks it's doing the right thing. Let's take a look at how word cloud normally works. No, it's going off into la la land here. It's probably doing something absolutely crazy. Let's just look at how word cloud works. We need the weight arrow, the symbol. Okay, so here we need to say %24. Well, let's say normal %24, and let's just be very simple-minded about this. #2 arrow #1 ampersand triple @ sign that. Okay, and then let's say word cloud of that. Come on, why is it so hard? Oh, I see. Free coin seems to dominate, but that's only because it has a large supply. Can we tell how many transactions have happened with each of these tokens?
Yes, there is. When you do blockchain token data, it gives you that information per token.
Oh, holders. Wait a minute. Transfers count. Oh wow. Okay, so I should have done this by. Okay, so actually, let me do this by. Transfers count, and then let me say reverse sort by. Why didn't that work? What did it do wrong? Reverse sort by that, by transfers count. What did I do wrong? I am very confused. Did I well, let's just say sort by. I mean, maybe there's some weird bug here, but I don't think so. Sort that by what is going on? Okay, I am officially confused here. I mean, it's conceivable that reverse sort by doesn't understand data sets. That would be absolutely shocking. That is so weird. Oh, unless reverse sort by does. Anybody understand that? Can somebody report that as a bug? Carla, could you?
Yes, I can report that.
Have somebody look at it. I don't know what went on there. Okay, so now let's do this. This is going to be more interesting. So that's probably some kind of zip distribution of. So if I were to look there at percent. Oh, I know what I did wrong. Maybe transfers count there. Oops. A magnificent distribution. I wonder if I were to take line 32 there, and I were to say log of that. Let's just take the log there. Well, I'm going to guess. Let's just find out. I'm just curious if that's exponential. Oops. What did it do there? Well, certainly if I say log of normal of that, it should work. What does that mean? That's some kind of, what is that? That's really weird. I mean, I would expect, okay, well, anyway, that's I would expect a Zipf distribution, which means it would be on a log-log plot. We would see let's just see what that looks like. Well, okay, fair enough. So it's kind of Zipfian until we really lose it here at the rare tokens. But I would guess here if we were to say let's see, take line 32, 100. This should give us a word cloud of the most popular tokens here. Yeah, okay, that's interesting. CryptoKitties. Okay, that's kind of cool. And we can presumably do that. Can we do that back in time? Like, could we see the evolution of this over time?
Yes, we can.
Okay.
But you will have to like make many calls, many blockchain token data, filtering by time, and it would be very computationally expensive.
Yeah, I understand. But I mean, we can get some snapshots at different times, like last year, such and such. Okay. Okay. Interesting. All right. So let's go back here. We were looking at the Ethereum case. All right. And this is, you're saying there's a, okay, why do I need to know stuff about gas prices? Because any transaction involves gas as well. Is that correct?
Yes, but but the thing is, you want the transaction to be mined, so you have to offer a good amount of gas. So that's what we compute, the highest gas price of the last block, and so you can use that.
I see. So it's like there's a certain amount of giving. What happens if you do not? I mean, your transaction might sit unmined for a long time. Can one see the unmined transactions, and how many are there? I mean, are there tons where people have just not offered enough of a bounty and they're sitting there unmined? Do we know?
Yes, there is there are no recording in the blockchain, but there is no certain way to know all of the unmined transaction because every node has a pool of pending transaction. So
fair enough. I see. So it could be fed to a particular node and never makes it onto the global blockchain.
Right.
But how many? I mean, nodes that we're putting up, how many random pending transactions do they wind up having?
I've not looked that yet, but we could do that. We could see in our node and count how many unmined transaction there is.
Okay. Okay. Well, let's try and look ahead at some of these. Smart contracts using Wolfram expression as a payload. Okay, so what's the idea here? Goal: to deploy an automatically executed Wolfram contract given by an expression to the Ethereum testnet and verify the execution of that. Okay, so what is the basic flow going to be here?
We're putting in this case, we're putting a Wolfram expression inside a Solidity contract, and then it gets harvested, executed, and the contract gets updated.
Okay, so that's our harvester that's coming and doing the harvesting. Is that correct?
Right.
Okay, and our harvester is up and running?
Mm-hmm. Yes.
Is it looking at just at the testnet, or is it looking at the production net as well?
It is looking at the production as well.
Yes.
Okay. So okay, that's very interesting. Okay, I didn't know that. Okay, so fine. So let's put. Okay. Wow. Cool. All right. So. And where is, if there's a bounty being paid to us for mining that transaction or for executing that expression, where does that show up? I mean, in other words, okay, so here there's a gas price here, we've got this expression. So when we make that transaction, we submit the transaction, then what's this here? That's the submitted transaction. And how do we see, wait a minute, where do we see this part of the transaction? That held expression?
In the next part of the workflow, when you do blockchain contract value.
I see. Okay.
It takes a few minutes to be harvested.
Okay, hold on. So how does it know up here? So our harvester is looking for a particular address, is that correct? Or what? How does the harvester work?
The harvester looks for a particular topic. If you scroll down a little bit, there is a property events in the blockchain transaction data output. And that topic is what the harvester is looking for.
What is events? I don't remember seeing this. That's a feature of the Ethereum blockchain?
Yeah. It is a way for the blockchain to communicate with the external world.
Okay, so explain that to me. So this has what is that typically used for?
It is used for the dApps, for the decentralized application, just for it is used for CryptoKitties. When you send a transaction to the to the store of CryptoKitties. The smart contract triggers an event, and some harvester that they've got in their own servers reads that in the blockchain, and they send a transaction that, yeah, okay, this CryptoKitty now belongs to you.
But I thought that the whole point of CryptoKitties is that the ledger of what belongs to what is on the blockchain. That sounds like they're maintaining a separate database.
Yeah, they are separating. They are maintaining a separate database, and they explain that in their website. And in order to make it would be very costly, very expensive if they didn't do that.
Well, but I understand, but there's still a ledger about who owns what, which is in principle disentangleable from the blockchain. Is that correct?
Yeah, that is correct.
I did not realize that they had a shadow database that was just, a centralized database in their server. How shocking. Because the point, because you're saying that to disentangle who owns what by tracing through that graph in the blockchain is complicated. Is that the point?
Yes. Well, they explain it in their website. It is not like it is no secret, that CryptoKitties own their own servers.
Yeah, I understand. But so that means that they know, for example, I mean, when people, as an owner of a CryptoKitty, you might own it through multiple addresses, correct? So you can't tell which CryptoKitties are co-owned. Which CryptoKitties are owned by the same person. You can't easily tell that if the person uses different addresses to buy different CryptoKitties. Is that right?
I am not sure. I think that one CryptoKitties it can be owned just by one address.
Okay, fair enough. No, I understand. One CryptoKitty, you can't have the same CryptoKitty owned by two addresses, but you can have the same address own two CryptoKitties.
Right, yes.
Okay, all right. So let's go back here. So what you're saying is, now, why is it the case? Why does it take 3 to 5 minutes for this thing? So wait a minute. The topic is, I mean, this is kind of shades of the Matrix, as in the movie The Matrix. This is we're watching for some topic to show up that our harvester will recognize to know that it should look at that transaction. Is that right?
Mm-hmm. Right.
Okay. So what is so we have a particular, like we have an IP address, we have a particular topic ID that corresponds to our harvester?
Yes, right.
Okay. How did we pick that topic ID?
The topic ID is just the hash of some string. In this case, is a fixed string. We hash it, and with that, it is just a fixed topic. It is just might as well be random, but that topic must be known by the harvester.
But we might as well have a cute string there, because this hash is not secret, right? We can have a cute string. I mean, at the very least, we can say, the Wolfram harvester or something, and have the hash of that.
Mm-hmm. Yes. Mm-hmm.
So everybody can reproduce. I mean, what is that hash, by the way? What kind of a hash is it?
It is an association that says something like Wolfram Harvester version 1, and we compress that association, and we got ourselves a string, and we hash that string.
Okay. All right. What do other people, I mean, we invented this name harvester ages ago. What do other people call that functionality of watching the blockchain for something? Since obviously that must be being done by, for example, the CryptoKitties, as you just explained, by the CryptoKitties central server.
Yeah, I wouldn't know how they call that.
Okay, all right. Well, okay, fine. So why does it take our harvester 3 to 5 minutes to notice this? if the blocks are getting mined every 10 seconds?
Right. So there are these blocks that are called orphan blocks. That it happens when at some point two blocks are mined, also two nodes mine the same block height, but with different transaction.
Yes.
So only one of the blocks gets into the blockchain, and the other one gets like drop, and those are called orphan blocks. So in order to for us to be really sure that the blocks is going to last in the blockchain, we have to wait for like 6 blocks, and there is around 2 to 3 minutes for waiting for confirmation.
But in general, right? In principle, it's like irreversibility in thermodynamics type thing. I mean, in principle, you could have to wait arbitrarily long to know that the blockchain is not going to reverse itself. Right, because it's just it's piling stuff on, but eventually it can. You're saying the probability of the blockchain of a block that has been added to the main blockchain, of that blockchain being reversed out through it failing to reach consensus, becomes perhaps exponentially lower. I don't know. That's again data that one could get. I mean, that would be interesting data to get, because do we have the information to get that data? We probably don't, because we only know the consensus blockchain, right?
Right. Yeah, we don't have that.
Okay. But okay, so basically you're saying we wait for consensus to be reached before we harvest the thing.
We wait for consensus, and then the harvester, in order to execute the contract, it deploys another transaction, and we have to wait for that next transaction generated by the harvester get mined. So
okay, but the harvester's transaction, how does the harvester get paid? Does the harvester get paid because a bounty has been offered on the original transaction that was submitted, or what?
No, well, currently we are not charging for.
But that's something we need. You will have to put an Ethereum address in the transaction that points to us.
Okay. So we need to figure out how to do that. I mean, presumably we don't want people to know. Okay, do we?
It will probably.
know.
I'm sorry. It will probably be the same mechanism as when as for the computational facts that we provide.
Yes, I would think so.
So we need to develop the same mechanism for both things. Yes.
Right, but so in particular, we don't want people to be able to tell on the blockchain which contracts happen to be using computational facts from us, presumably. Or maybe we do, I don't know, maybe it's good marketing to be able to go look at the topics and see there are zillions of Wolfram Harvester topics there. Do you know what I'm saying? Or is it considered problematic that somebody can tell, I mean, which contracts happen to make use of computational facts from us? I'm not sure. Maybe John has an opinion about that.
Not really, although it does highlight that we should review other smart contracts that are using facts out there.
Yeah. Well, okay, fine. So we should determine the answer to that. But basically then this whole transaction will get a bit more complicated, because it will also be sending to an address some amount of cryptocurrency. How do we determine what is the price list for computational facts? In other words, if somebody asks to, if for their computational fact they ask to discover the next, Mersenne prime or something, right? Something that's going to burn tons of CPU time. How is this supposed to work? Is it supposed to work that basically you say, I will, that you test the computational fact query, you say that takes X number of cloud credits. That number of cloud credits translates into this price on the blockchain. therefore I will offer you this bounty on the blockchain to do this computation. Is that what we expect to have happen? Guys?
Can you say again, please?
Okay, so look, what I'm imagining is that there is a version of this transaction that requests, that says, I'm providing this Wolfram language expression that I want evaluated. That is the thing that is going to determine my fact. Okay? Okay. I'm going to say, presumably I'm going to test this. So I'm going to know this type of fact takes 3 cloud credits. Actually, we're now unifying that system. So like 3 Wolfram credits to compute. Okay? I then look up a price list that says 3 Wolfram credits equals such and such a number of Wei on Ethereum. Okay? I then say, great, I will put that price in Wei as the thing that I am paying to get the harvester to do its cycle and return the results of evaluating that expression to the blockchain. Make sense?
Yes.
Okay, but we're going to have such a, there's got to be a price list, and it's got to be, presumably, there's the market price on the day for that number of computation credits. And in principle, that market price could float if, for example, other people offer the computation services, for instance. But in other words, somehow it's got to know when you set this up. So one thing that I don't quite understand is there's sort of a futures question, because what has to happen is you say, I'm going to set up this contract. One day it's going to trigger, and it's going to want to know the temperature in Timbuktu that day. Am I making sense? But that day might be 6 months from now or a year from now. Okay? I know it's going to cost 3 Wolfram credits to do that computation. Okay? But the question of how much, the price of Ether has gone up or down, what is the conversion rate between, what do you have to put into your contract on day 0 to make sure that you have enough? I mean, I guess it's basically gas in there except I'm not sure are we using gas or are we using Ether to do these things? Isn't Ether, gas what? Yeah, I think we're using Ether because gas is only used for internal solidity execution. Okay, so we're using Ether. So now the question is, what happens if when you set up this transaction, the price of Ether was X? When the transaction comes to be executed many months later, the price of Ether is something different, right?
Right.
So for us, or whoever is providing computation services, they basically, it's like it's like futures or something. You're saying, I will offer to do this transaction 6 months from now. I will offer to do a 1 Wolfram credit transaction for such and such an amount of Ether. Am I making sense? Am I confused somehow? I mean, it's like saying, and then in principle, somebody's making a lot of background noise here. In principle, one could imagine being able to resell that contract. I mean, essentially, that's a contract to perform that computation at some point in the future. Am I making sense?
Yes.
So, and in principle, one can have a secondary market or even a primary market of saying, okay, it's not worth my while. Okay, so first of all, some of those computations, some of those transactions may never happen. That is, the other set of circumstances that cause that smart contract to trigger may never actually ask the computation to be done. So it could be that somebody paid you. Oh, I see. You don't get paid in this model, which is not obviously the correct model. You don't get paid until you actually do the transaction. It's not obvious that that's the right model.
It doesn't seem like it.
Right. I mean, but
there's an awful lot of risk in that. in having to execute that contract in 6 months.
Yes, but how would this work if you had to get paid up front? Because if you get paid up front, how do you know that then it requires a different protocol and maybe some token mechanism or something for you to be able to say, I'm going to get paid up front, and then this contract will be set in a state. This thing will be set in a state where when it is requested, it will be computed. That makes sense? Yeah, I mean, it makes much more sense. I agree with you, because otherwise you're in this futures business. It makes much more sense to say pay now. It's going to cost this number of credits, of Wolfram credits. Pay now, and then, okay, so guys, I think you need to figure out what the protocol is. Do you get what I'm saying, Johan?
Yes. Yeah, but I think there might be many more cases than this, so we actually have to figure out a bit for every one of them. So I think that if you put a contract that has to be executed in 6 months, then you probably use the price at that stage, and that's it. Or you could prepay for, I don't know. There should be many cases to think about, but yes, I see what you mean.
Right. Okay, so actually another thing which I'd like to bring up here, what if we were storing data for somebody? What if in our cloud we end up, let's see, how does this work? I mean, maybe I'm just confusing myself, but let's imagine that I want to put some data somewhere, and then I see, and then in 6 months somebody else, well, okay, right. So there's a bunch of cases there. That's I think a different thing. But as soon as we can do these, as soon as we can do an arbitrary evaluation, that evaluation could put data into our cloud. In other words, we could do an evaluation, a computation that where one contract saves data into the cloud and another contract knows the same address and can retrieve that data later. Am I making sense?
Yep.
I mean, in other words, there's persistence. There's nothing. If we are assuming that every transaction, every computation sent to the harvester is executed in the same cloud, right? Then it will be the case. Yeah, I mean the alternative is to require that the thing be stateless, so that, for example, it could be the case that there's a whole swarm of clouds, so to speak. It's a whole storm of clouds or something that are so you don't necessarily know when you ask for this transaction, for this computation to be done. You won't, because it's stateless. You don't know in advance which machine is going to compute it, and then obviously the limiting case is the absurd case of Ethereum, where all the nodes compute it. But that's, I think, utterly unnecessary. If you have a large pool of nodes and a randomly chosen one computes it, or in the most extreme case, 3 randomly chosen ones compute it, you're pretty safe. But so that's a case we don't really understand, is whether the expression that we give is a stateless thing that will give the same answer whenever it's computed, or whether it can store state. Okay, but anyway, so we obviously need that protocol. Oh, look at this, smart contracts working with external storage. What do you know? That's the next item here. What is this? Why do we need, you have this whole diagram. Why do we need this? Why do we need, so in the first case, we're putting the expression that we want evaluated raw onto the blockchain, right?
Right.
Okay. The second case, what if we want a 1,000-line program executed? then the idea is to store the 1,000-line program in IPFS, to retrieve it, execute it, and give the result. Is that correct?
Yes.
Okay. Now, as a practical matter, which do we expect to be the more common? I mean, okay, so if you had built, I see, the whole point is that you want it to be a raw, stateless Wolfram cloud in general that executes things. So you can't, for example, have stored an API in the cloud that just does your 1,000-line program or 1,000,000-line program or whatever it is. Is that right? You want it to be stateless so that any Wolfram cloud anywhere could execute it.
Yep.
Okay. Let's see. We have all kinds of comments on the live stream here. All right. Michael says, I think I get it. It could be code that depends on the exact time it is run. Let me understand this. Okay, that's an important point. The code depends on when it's run, like it's asking for the current date. So one question is, what is the user metadata of code that is being run from the harvester? Do you get what I'm saying? Like for example, if you're running something in the cloud knows the IP address. If you run an API in the cloud, that API gets to know the IP address of the caller. Get what I'm saying? And certain other user metadata. So a question would be, so this is, if we look at, what is the name of that variable? Gosh, I should remember. Dollar evaluation environment. Okay. So the harvester represents, so we have certain evaluation environments. Like, for example, it is evaluated in a, here are some cases, right? A subkernel that's a web evaluation, cloud evaluation initiated by an HTTP request. So there will presumably be another evaluation environment for the harvester. Is that true? I think so.
Yeah, I haven't checked this yet.
I think it's what we'll want to do, because this will get, see, the whole point is when you do that, right? So if you say user metadata, if you look at the user metadata, cloud execution metadata, okay, so this shows you, for example, if you are being executed as an HTTP request, you get this HTTP request data sent to you as part of the, you can retrieve this, when you execute that particular computation. Get what I'm saying? So there's a question of how much metadata do we pass to the harvester when we tell it to do the computation? What do we know? We know a bunch of stuff because we know which block the harvester picked this thing up from, et cetera, et cetera, et cetera. We know a ton of stuff. We basically know the transaction that contained this request, and we will want to send that, just like we know the transaction, the HTTP transaction that contained the request that we're now executing. We have the same kind of thing for the blockchain. Make sense?
Yeah.
So, my guess is it's going to be basically the same as the contents of blockchain transaction data, just like this is the same as the contents of an HTTP request packet. Right? If I look at this HTTP request data, okay, let's try to understand this. This HTTP request, right? What we get from HTTP request data is the cloud side view of the incoming HTTP request, I believe, plus some other stuff, some other metadata like the IP address it's originating at. Anyway, we need to understand the analog here. Okay, but the question, let's see. So Michael is saying, so I guess the harvester code will be official and you would instruct it to write any important results you want to appropriate addresses on the blockchain. Well, now what are we actually doing? So the harvester result right now, you are saying where to send it. Is that correct? In the original setup, you told it where to send the results from the evaluation. Is that true?
Yes.
Okay. Carl is asking about Wolfram credits, and I'm not at the front lines of that. The main issue is that we have had separate credits for using cloud CPU time and using external services like sending text messages or calling external APIs. And there is a whole scheme for merging these, and I can't claim to understand it. The difficulty is that some of them are things that are under our control, how much they cost, and other things are not under our control, how much they cost. But I think by having essentially exchange rates, we can control that. I think that's coming in the next few months. Okay, Ben is saying he's interested in the use of blockchain for health records and health statistics. Yeah. So we've been involved in a bunch of folks talking about that. I think that you're the best. Maybe can somebody say, John or somebody else say what the current thinking is about the protocol for how you would do medical record stuff on the blockchain? I mean, in a perfect world, you might use, fully homomorphic encryption to be able to write medical records to the blockchain and be able to then compute with them while they remain encrypted, so to speak. But absent that, what's the protocol? What's the workflow for doing medical records stuff?
I mean, now that I kind of think about it, what's likely to happen is that someone's going to create a more specialized DLT just for dealing with medical records. That's likely more likely to happen than someone sort of looking at existing DLTs that are out there and trying to come up with some solution. Do you know what I mean? Like,
yeah, well, but I mean, in principle, you could use our blockchain to just throw data. I mean, our blockchain lets you put data on there, but that's not really the use case. The use case is that you want to be able to, globally store. I mean, I think it's more of an IPFS like play, actually. You want to be able to globally store things in essentially a global database and have, I mean, the difficulty is who gets to access it and who gets to access which pieces of it, I think. I mean, I don't even know how it works. And, if you have, let's say you have your electronic health record and it's held by some particular, you go to some, medical practice that's part of some hospital chain. And then you want to go to some other specialist in that hospital chain. What do they actually get access to? Do you know? In other words, do they get either full access to your medical record or they get nothing? Or is there some mechanism for giving them partial access?
I don't know. That's a good question. But I do know that each organization has their own, structured system of medical records.
Well, I know, but I'm asking, if you just buy your system from Epic or something, then is it the case that specialist
compatible?
What's that?
I think each one has their own system, like even of Epic.
I see.
Something where
with different schemas and things or something.
Yes.
But I mean, the question that I'm asking is, specialist 1 gets, puts certain data into your medical record. Does specialist 2, if they see anything, do they automatically see what specialist 1 put into your medical record? I mean, that's something we can obviously determine. I don't know the answer to that. But, I mean, that's presumably it would be, that's the type of thing which with the right encryption mechanisms and so on, one could segment things in a nice way. And one could have something with multiple signatures and things that are required for certain kinds of things. But presumably, I mean, we've interacted with enough of these people trying to do this. Somebody must have spec'd this out, I would hope.
Right, but I mean, I think that's where it would be more interesting to have your custom ledger that actually stores the medical data on.
Oh, sure. You don't want to store it. You're not going to store medical data on, you're certainly not going to store it in some way in the Ethereum blockchain. That's completely senseless. I mean, the only use case there is the case where you put your medical records there, and you say a pharma company can look at my records by paying me X number of X amount of money.
Right.
That's that case.
Right, having some pointer to the actual records, but and that's why I'm saying, like, I think the people who are actually going to solve the problem in a reasonable way are just going to rethink and create a custom medical data ledger and get people.
No doubt, and it might cross-connect with the public cryptocurrencies for in order for there to be some possibility of people buying stuff through cryptocurrencies if they want to do that.
Yeah,
but
go ahead. Sorry.
Yeah, no. Well, anyway, let's see. Michael on our live stream says, I wrote like 1,000 lines of Solidity code last year for an order booking and bidding system somebody wanted. Users had to transfer the max amount of Ether they were willing to pay with their bid. Then the behavior of the open source contract would automatically refund them if their bid wasn't selected. Okay, interesting. By the way, for that case, what do we imagine? What are we going to provide in the future that would allow that contract? I mean, are we expecting that we are going to compile to Solidity for certain kinds of from certain kinds of code? So we're going to compile to native, let's say Ethereum smart contracts. Is there some possibility of that, or are we not imagining that's going to happen right now?
No, that's one of the projections we have.
But is it going to work through LLVM and through the compiler, or is it going to work through another mechanism?
Probably through a compiler.
Okay, but there are specialized operations that exist in Solidity that presumably are not, that right now I don't think are part of our language, and so wouldn't be picked up by the compiler. In other words, what if when we write the Solidity, the Ethereum virtual machine, right? How far have we got in writing the Ethereum virtual machine?
We have a good progress there, and we are actually talking about the building the Solidity compiler.
Wait a minute, that Solidity compiler, which way round of a compiler are you talking about?
We're still discussing about that, but about the virtual machine, we have basically all opcodes implemented.
Okay, so then which of those opcodes do not have an analog in Wolfram Language? I mean, clearly opcodes that say add this to that, they have analogs, right? But there are opcodes that don't.
I think the ones that require access to the blockchain, to the Ethereum blockchain, and that needs that Ethereum context there. So that's something we still.
Can I see? Could you show the progress of the EVM thing? Is that
sure? Just let me get the notebook 1 second.
Okay. Do you want to send it to me, or do you want to show it on your machine?
I can send it to you.
Okay. Why don't you do that? Boy, we didn't even get through all of these workflows. This is terrible. This is a complicated subject. When are we going to have our course about this, guys? How is that coming along?
Well, I think we're working on the non-public stuff too. So.
Right. Well, it just seems like we've got a lot of good material here to by the way, I don't understand why, other than because your incoming or outgoing data is large, why would you use external storage for a computational fact? What's the point of having this in external storage? Why don't you just have it as part of the payload on the blockchain itself? unless it's big and you have to have a pointer. I mean, it's the difference between cloud evaluate and executing an API in the cloud. Or is there a different reason? Is there a reason like you might want the code to be secret? Do you see what I'm saying? That somebody might, in a third-party case, somebody might want to write code that they say, this code is going to be an amazing thing. It's going to predict the stock market, and you just have to call it, but you can't see my code.
Well, that's one of the reasons. Other than it would be, if the code would be too large, it would be more expensive to store it in a smart contract in Solidity as well.
Why is it how does this price vary with the size? I thought it just had some size limit, and you just put the stuff in up to that size limit. You're not paying, to my knowledge, although you perhaps should be, you're not paying to have everybody replicate, your stuff throughout the Ethereum blockchain. You're only paying the cost of replicate this transaction, right? You're not saying it isn't counting the number of bytes and saying we'll charge you more because it's more bytes. Is that correct?
No, it does count the number of bytes.
Really?
Yeah, so you pay more depending on the size of the smart contract.
Through the gas price?
Through the gas price. Yes.
Okay. All right, well, let's take a quick look here. Smart contracts using Solidity.
I just sent you the EVM interpreter.
Okay. And what okay, let's take a look here. My gosh. So is there something runnable here?
There are some examples at the end, yes.
So I have to execute. Does this have initialization cells in it? Or do I just execute all this stuff at the top? What do I do? Oh, it's got initialization.
Yes.
Okay. I don't know what that wrapper is. Okay, testing examples. Okay, so let's go ahead and say this. Oops.
No, just run the scroll up and run the
wrapper.
All those cells.
Oh no! So I see. I have to actually
run. Yeah.
It's not an actual initialization.
Right.
Okay, let's try it again. Okay, so this is add 2 and 3. Okay, what on earth am I seeing there? So are those the successive states of the EVM? So that's in a sense the tape of the EVM is blank. And these are the registers of the EVM? Is that right? I think it would be good. Didn't we have a spec for this? I think it would really, really be good to give the state of the EVM as an association that lists the state of each register, et cetera, et cetera, et cetera. I think that was the original spec that I'd made, at least. Should I pull that out again? Let's see. Did you have that still? The do you have that information?
Me? And yes. I don't have that.
Well, but you must have had it at one point because we had an actual.
Oh, no, you're talking about, I think, the Bitcoin interpreter.
Fine, but I had a spec for how to represent virtual machines. Right? Remember that?
I think so. I'll have to look for that.
Okay. So let me see. I wonder what this is. Well, I've got several of these. Let's take a look. That's not it. Hold on. I think I should be able to find it. Let's try this. Okay, that's an old thing here. That was an old version. I don't know when that's from. Oh no, that's an old thing. Let's take a look here. That's a different thing again. Wow, it's from a year ago. It's interesting. Okay. Okay. Well, I'm certain that I gave you this. So let me just see. One more place it might be. Yeah, well, I had some notes here. But this was very minor. There were many more notes for how this should work. Okay. So, I mean, the basic idea is what it should eventually have is a virtual machine function, right? Which can list a bunch of opcodes, operate on a state, and return a new state. Make sense?
Right.
Okay. So for instance, so that's not what this is doing. That's taking a script. Oh, I see. No, that is more or less what it's doing. But this is, I mean, the analog of this, for example, for a okay, this is the analog for register machines. Okay, it has the exact same type of thing. It has an execute and it has this evolve list, which is giving the successive states of the machine, which is essentially what you're doing here. Right? That makes sense?
Mm-hmm. Yep.
Anyway, I strongly believe that you should represent the state of the machine by an association. I don't even know what these things are. These may be operands, what the hell are they called? Operands for that opcode, but I don't understand any of this. I'm sorry. I don't understand what is the 100 there? What does that represent?
I'm not completely sure. I mean, we still have to work on the design, so we have all this backend.
Yeah, okay. Well, this looks nice, though. What's that? That's some symbolic representation of a hex value? That's weird. So that's, again, I mean, these are the kinds of things we need to understand is what new constructs do we need to have to support what is being done with the EVM? I thought we had a project at the summer camp, I think, to implement Knuth's Mix virtual machine. Did that ever happen, or was that simply on my list and nobody picked it up?
I don't quite remember. I can check.
Okay.
I remember the Knuth machine.
Right. I mean, that's just an example. I mean, eventually we could have 8086 machine code here as well, if we wanted to. Okay. I mean, another thing that'd be fun to do is random programs here. See what the random EVM program actually does. I've never really done that. I did that experiment like 25 years ago with some risk, some kind of risk instruction set, and it was very uninteresting. I mean, it just most sequences of instructions, the thing crashed. Michael on a live stream is saying that the 100 might be a gas amount, and I agree with that claim. Yeah, I
found
that might be using progressively more gas here, possibly.
I found the post about the MMIX machine.
Okay.
Can I share that on the Zoom chat?
Yeah, go ahead. Okay. I see. That's a bit of a mess. Okay. I see. So then it took code from Don Knuth's books, and then did he successfully parse it? Yes. Okay. Oh, that's cool. Well, why doesn't it show it actually running? Well, okay. Or maybe he didn't get all of the opcodes implemented. Anyway, but look, we need a standardized way to represent virtual machines, and I would suggest, I mean, we can do another discussion at some point to go through that. But I think just like those register machines that, the theoretical register machines that I have. Okay, so these are extremely simple machines, right? So this is a machine where it has a program counter position within the program, and it has two registers with content. So that's the position of the program counter. Those are the values of the registers. Make sense?
Yeah, I think so. Yeah.
So one would assume that the way this works is that there's a thing that says program counter, arrow, and then value, and then, register values, maybe arrow, and then whatever's in the registers, right? And that's the state. And then this program, that program consists of simply saying increment, this color coding, gray coding, says that's increment register 2, increment register 1, decrement register 1, and this machine has a decrement skip on 0, as I recall. Make sense? So what it's doing is if that reaches 0, right, so you can see what it's doing, right? Every time the thing reaches instruction 3, that thing executes the yeah, I see. So on the decrement skip on 0, the skip has to say where its destination is in this model, right? So it's saying go back, set the program counter back to position 1. Make sense?
Mm-hmm.
So what you would see here is, as that code I was showing will just generate a series of, program counter is 1, program counter is 2, program counter is 3, register values are blah, 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 right? And so, for example, well, there's an example of a more complicated machine, program, right? Operating within that same machine. And then what you would do is you specify the program, you specify the initial state, which in this case here is program counter 1 and register values 0 and 0. Okay. Then you simply you're saying how many steps do you want to run the virtual machine for, and you run it and it will do what it does, right? Is this making sense to people? And in order to, you should be able to make this graphic by basically just picking out the values in there. And I don't know whether, in the case of the EVM, whether there's a notion of program counter. Is there? There must be. There must be, because it must be able to. It can do loops, right? It's got to be able to do loops. Yes.
It should be able to do loops, yes, because it's
okay. So these are register values, I assume, right? So I don't know what this means here, but it's got to be able to, well, jump dest. What does that mean, I wonder?
There's a link at the top of the notebook, I believe, to yellow paper.
Okay, but so to represent okay, you've just got to be able to represent the state of the machine, and I believe the state of the machine is the memory plus the program counter. Does that make sense?
Yeah, I think so. I think there's an appendix with the opcodes.
Okay, I'm gonna have to go a second here. So I think we have to continue this meeting because I think there's more to understand. We've clearly unearthed a few issues which we were not aware of. And hopefully we'll have a good crisp set of things to say in about 2 weeks at South by. Right, it will be nice to, okay, so do you want to have a separate meeting to talk about virtual machines and how they should be set up? I think we kind of are going to need that. And I would recommend that we plan on using the register machines from the NKS book as kind of the zeroth case. Does that make sense?
Okay.
And I don't know. Okay, let me explain one more thing. So typically these virtual machines, they have registers and they also have main memory, more analogous to the tape of a Turing machine, for example. Okay, rather than the registers of a register machine. And I don't know how we should deal with that in the representation of the virtual machine. So Michael is saying his experience in coding in Solidity last year was that it was easier in the assembly language, but more tedious than C. No floating point numbers, had to convert everything into integer operations on rationals, tracking separate numerators and denominators. That sounds like a joy. Had to write separate list append functions for every data type. Yeah. Yeah, interesting. Well, I mean, then the question, okay, so you understand there's an issue how to represent main memory. Can you, I mean, I believe those are the things that computers have, basically, is, you know, right? We may need to, if we're going to do a discussion about virtual machines, we may need to get somebody in there who knows about machine code level programming in detail. So we should figure that out. There's probably somebody in Warren's group who knows that, possibly somebody, oh, maybe we just need one of the older people in the company, like me, who's actually programmed in assembly language at some point. But that's what we're going to need to have a meaningful discussion about that. But okay, so virtual machine discussion is one discussion. Okay, I think we need to finish going through these. I don't understand this here yet. What is this? So this is Solidity code. What's the point of this? So Carl on the live stream is asking, can we use the new compiler to convert Wolfram language code to Solidity code? That is a good question. That depends on whether there is an LLVM to Solidity converter. But no doubt our intermediate code for the compiler, which is symbolic intermediate code, would be a good intermediate code for final conversion to Solidity. But that's a whole separate thing to create the code generator that goes from the intermediate representation to Solidity code. And it would be easier if somebody else has already written an LLVM to Solidity converter. Why are we, what are we looking at here? Okay, great. So this is a library that does trivial, I mean, I don't understand. And by the way, when you use Solidity, presumably every part of the code you're using has to be included in the blockchain And that presumably, since you're telling me it costs gas to store stuff, that means your contract has to contain all of the code. Is that true?
That is true.
Okay, so Carl said he's found one that goes the other direction from, I see, from EVM to, this is from EVM. What does this do? You know, I find it so infuriating that these things, it's just like, okay, is library for just-in-time compilation. Okay, right. So it creates LLVM code from EVM. Makes sense. It allows you to run EVM in an LLVM virtual machine. Okay. So what's this? This is, what on earth are we doing here? This is using that Solidity code. What are we doing here?
We're trying to deploy a Solidity contract.
Okay. And what's that contract supposed to do?
It outputs a Fibonacci number. It is just a simple example, but it is written in Solidity.
I see. Okay. So this is our type specification translated, a version of our type specification for Solidity.
Right.
Okay. Okay, this is a different thing. All right. Well, I think we have to continue. Great. Well, that was useful, at least for my understanding of things. Terrific. Okay. Well, thank you all, and thanks to folks on the live stream, and talk to you later. Okay. Bye.
Thank you.